In this section, we're covering methods of cryptanalytic attacks, specifically focusing on frequency analysis. Frequency analysis is a fundamental technique in cryptanalysis, especially used for breaking classical ciphers. This method helps cryptanalysts understand the structure and weaknesses of a cipher by examining the frequency of letters or groups of letters in the encrypted message. By leveraging patterns and commonalities in language, frequency analysis can reveal the underlying plaintext and break the encryption. Let's dive into how frequency analysis functions and why it remains a significant tool in the field of cryptography. In this slide, we will cover an introduction to frequency analysis. The objective here is to help you understand its basics within the scope of cryptanalysis and recognize its relevance in breaking classical ciphers. Frequency analysis is an essential tool for cryptanalysts. It plays a significant role in deciphering weak encryption schemes by examining the frequency of letters or groups of letters in a ciphertext. Grasping these concepts will strengthen your understanding of how classical ciphers are broken, which is fundamental for any cryptanalyst. Frequency analysis is a technique for examining the frequency of individual letters or groups of letters within a ciphertext. Historically, it played a key role in decrypting classical ciphers such as the Caesar cipher and the Vigenère cipher. This method involves monitoring how often each letter appears in the encrypted text to detect patterns. Although it is no longer effective against modern encryption methods, understanding frequency analysis is foundational in the study of cryptography. Now let's discuss the core principle of frequency analysis. First, it's important to understand language characteristics. Every language features a unique distribution of letter frequencies. For instance, in English, letters such as E, T, and A appear more frequently than others. This predictable pattern is key in analysis. Second, by examining these frequency patterns in ciphertext, we can make educated guesses about the plaintext. Essentially, you compare the frequency of letters within the ciphertext to the known frequency distribution of the target language. This comparison helps to uncover potential matches and derive meaningful insights into the encrypted message. Understanding these fundamentals will prepare us for the practical example we'll go through next. In this slide, we'll walk through an example of breaking a Caesar cipher using frequency analysis. Let's consider the ciphertext GDKN-VNQKC. First, we count the frequency of each letter. G appears one time, D appears one time, K appears 3 times, N appears 1 time, V appears 1 time, Q appears 1 time, C appears 1 time. Next, we compare these frequencies with the known frequency distribution of letters in English. For instance, since K appears most frequently in the ciphertext, and E is the most common letter in English, we might hypothesize that K in the ciphertext corresponds to E in the plaintext. By continuing this comparison and shifting the letters accordingly, we aim to uncover the original message. This method leverages the predictable nature of letter frequencies in the English language to decode the text. Now that we understand the principles of frequency analysis, let's see a practical application by decrypting a Caesar cipher. We'll use Python and the collections module to perform frequency analysis on our ciphertext, GDKKN-VNQKC. Here's how we can implement it. We start by importing the counter from the collections module. We'll define a function called frequency analysis that takes the text as an input and returns the frequency count of each character. When this function is applied to our ciphertext, GDKKN-VNQKC, it will count occurrences of each letter. Finally, we'll print the frequency distribution to see which characters appear most often. This approach helps us identify patterns in the text, making it easier to break the cipher. Let's look at the code. Python from collections import counter. Def frequency analysis text. Return counter text. Ciphertext equals GDKN-VNKC. Frequency equals frequency analysis ciphertext. Print frequency. You can see the character frequency distribution printed out, which sets the stage for identifying potential shifts and cracking the cipher. Now, let's turn our attention to modern tools that significantly simplify the process of frequency analysis. One such tool is Cryptool. Cryptool is an open-source software designed for educational purposes in the field of cryptography. It comes packed with a variety of features, making it an excellent resource for performing frequency analysis on ciphertexts. To use Cryptool for frequency analysis, you simply input the ciphertext into the software. Cryptool then generates a frequency analysis chart, providing insights into the most common letters in the ciphertext. This can be particularly helpful for identifying patterns and making educated guesses about the plaintext. This functionality streamlines what traditionally would be a time-consuming and meticulous process, making cryptographic analysis more accessible and efficient. In this scenario, we're tackling the Vigenère cipher with a ciphertext of LXFVFRNHR and an unknown key length. The first step is to perform a frequency analysis on various segments of the ciphertext. This will help us identify patterns and possible repetitions. Subsequently, we'll apply the CISSP examination to determine the potential key length. Identifying the key length is critical because it narrows down the possible combinations and makes decrypting the message feasible. When exploring best practices in cryptanalysis, it's essential to first understand the limitations of the techniques we use. While traditional methods like frequency analysis are effective against older ciphers, such as the Vigenère cipher we've discussed, modern encryption algorithms like AES and RSA are designed to be immune to these types of analyses. Despite these limitations, frequency analysis still has legitimate uses today. It remains an invaluable tool for educational purposes, helping students grasp fundamental concepts in cryptography courses. Additionally, it's widely used for analyzing historical encrypted documents, providing insights into the methods of encryption used in the past. Understanding these nuances ensures that we apply cryptanalytic techniques appropriately and appreciate their role in both learning and historical research. On this slide, we'll be wrapping up with a summary and some key takeaways from what we've covered regarding cryptanalysis. Key points. Frequency analysis is a foundational technique in the field of cryptography. It's the primary method used historically to break classical ciphers. However, it's important to note that modern encryption algorithms like AES and RSA are designed to be resistant to such attacks. Next steps. To solidify your understanding, it's highly recommended to practice breaking classical ciphers using tools such as Cryptool. This hands-on experience will give you a practical grasp of how frequency analysis works. Additionally, for those looking to deepen their knowledge, studying advanced cryptanalytic techniques will provide a more comprehensive understanding of the field. In essence, while frequency analysis is a critical skill for understanding the basics of cryptanalysis, mastering modern cryptographic methods requires a deeper dive into advanced techniques. Now, let's move on to references and further readings. To deepen your understanding of cryptographic methods and cryptanalysis, I recommend several valuable resources. For comprehensive study, consider the book Cryptanalysis, a study of ciphers and their solution by Helen Fouche. This work provides a solid foundation in deciphering classical ciphers. When it comes to practical tools, Cryptool is highly beneficial. You can explore it further at http://w.org/. Cryptool offers a hands-on approach to learning about classical and modern encryption methods. If you're inclined towards learning cryptography implementation, visit tubmo.python.org/ to get started with Python, which is an excellent language for coding cryptographic algorithms. Lastly, for more structured learning, check out the Introduction to Cryptanalysis article available on Pluralsight. This will give you a good start in understanding the basic concepts and techniques in the field. In this course, we aim to build a deep understanding of cryptographic principles and their practical applications. By referencing key texts such as Cryptanalysis, a study of ciphers and their solution by Helen Fouche, and leveraging tools like Cryptool and Python for cryptography, we will illustrate how these concepts can be applied in real-world scenarios. For those looking to explore further, articles such as Introduction to Cryptanalysis on Pluralsight provide a solid starting point. By the end of this course, you should have a well-rounded comprehension of both the theoretical and practical aspects necessary to approach cryptographic problems effectively.